In the video today, we'll be using the sine rule to help us find an angle instead of a side. In our previous lesson we had a look at, or previous video, we used the sine rule to firstly go, okay, this is how we label a triangle when it's a non-right angled triangle. And we use the sine rule to help us find an unknown side length. In this case, it was x each time. Now, we can also use the sine rule to help us find an angle, okay? So in this case, we want to find theta. Now, what we have to know first is just a nice little shortcut into doing this. So you may see up here, and I will eliminate or get rid of this blacked out section here. We can either find a side in the sine rule using A on sine A is equal to B on sine B is equal to C on sine C. This is for finding sides. Now, this is the identical equation over here, but it's very, very useful to use this equation when finding angles. Reason being is we've got all our unknowns on the numerator, so we don't have to do another couple of steps to solve the equation. So whenever we're finding an angle using sine rule, instead of using A on sine A, it becomes sine A over A. So it's like the reciprocal of this here. So we're going to use these equations here for the sine rule to find angles. So without further ado, let's have a go at finding the angles using the sine rule. So we're going to find the angle here for when theta is here. What's our first step in solving any equation with the sine rule is firstly labeling our triangle. So A, B, C. Our next step is that to find the opposite edge. So the opposite side of A in this case is the 9 edge here. So I'm going to write small a here. Opposite of B is small b. And opposite of big C is small c. Now you may note that C in this case doesn't represent the hypotenuse anymore. It just represents the opposite side to C. Now we want to substitute in using the sine rule equation for angles. We know our A's and we know our C's. We do not care about our B's. So if I went up to this equation here, I'm going to be eliminating my B's. So it's going to look something like this. Sine A over A is equal to sine C over C, because we don't care about the B's. Okay, so our first step after labeling is to write out the equation. We have that there, sine A over A is equal to sine C over C. Now that that's loaded up, we're going to substitute in the values we know. So sine A is going to be now theta. So we write sine theta over A, now A in this case is 9, is equal to sine C, angle C is 83, over our small side C, which is 10. So let's do this by hand firstly. If we times both sides by 9, we get sine theta by itself and we don't get theta by itself just yet. What's the function that helps us eliminate this sign on this side to get theta by itself? Well, it's inverse sine, like that. Now, when inverse sine comes together with sine, they eliminate, and we're just left with our theta. What we do to one side, we're going to do to the other. So what we need to do is type in inverse sine theta of all this to find our angle. So let's type that in now. So we can just write this all in. Firstly, sine theta, and this is in our trig part. Make sure your calculator is in degrees, and then go shift divide and put in 9, shift 1, 83, close your bracket on 10, and we should get an answer of 63.29 degrees. Now, it does say that theta is acute, and we're just going to experiment with something here. We're going to try putting this into the solve function of our calculator. So let's chuck that in, and I'm just going to copy this from above, that was from our previous example, and put in our values. Now you may note, and I'm just going to delete these bits actually, shift divide, and then on this side shift divide, and here we're going to put in sine theta. So you don't have to use theta, but we do have one there, so we may as well use it. Sine theta, close our bracket, over 9 is equal to sine 83, close bracket, over 10. Then press execute. Let's see what happens. It says no solution. Seems a little bit unusual. So I'm just going to try an x instead and just see if that works. Okay, so we get all this here. So let's just use x from now on. Now you may note we had here our answer of 63.29 degrees, yet this hasn't popped up well at all. So we're going to put in a given that, and it's shown down here as well. A given that helps us find an unknown within a range. So we're going to say given that, okay, and this button here is located in Maths 3, given that 0, and then we put 2 of these, and we say that x has to be within 0 to 180 degrees. Execute. And we get 2 answers pop up. Now, in this case, this is called the ambiguous case. We have a 63 degree angle, which is this one here, but this angle can actually be obtuse instead and be 116 degrees. So in this case, we're only looking at the acute, so this is our final answer. So, pause the video and have a go at the your turn, and when you're finished, to check your answer, press play. We're going to have a look at the your turn now. So, our first step is to label our triangle. A, B, and C, and then the edges, small a, small c, and small b. Now we decide what sine rule we use. Well, we've got our c's and a's, so we're going to use sine big A on small a is equal to sine big B on small b. The next step is to substitute the values in. So sine of big A, which in this case is theta over 3, is equal to sine angle B. Apologies, we're going to use C, aren't we? There we go. And that will be 100 degrees over 5. Now in this case, I'm just going to use the solve function as I think this is easier. We go on 3 is equal to 100 over 5. Now we always keep this bit in here, 0, x to 180. So what we're saying is that we're telling the calculator to only look at this angle here to go from 0 degrees and stretch out all the way to 180. A triangle can't go any further than that. So when we press execute, we get 2 answers. We've got 143.78 and 36.22. Now which one's an acute angle? Well, anything from 0 to 90. So therefore we'll only choose the 36.22 degrees. Now it does say to 1 decimal place, so we'll choose 36.2 degrees. So theta is equal to 36.2 degrees. And you may note over here, I should have gone to 1 decimal place. I'll clean that up now. 36.3 degrees. And I'll put in brackets 1 dp. This is our answers. We've now finished the sine rule questions, okay? And we'll move on to how to find an angle using the sine rule for an obtuse case in the next video.